I'm doing example 6.1 from the notes, and I'm going to be teaching how to find the bottleneck and throughput of a system. So this is given, so that gives you the number of employees, the process times for station A, and the process times for station B. It also tells you that it's an 8-hour workday. The demand for station A is 50 units, and the demand for station B is 40 units. So to find the bottleneck and throughput, you have to go through this process. So we'll take the first available capacity, which is calculated by taking the number of employees for station 1, that would be 2, times the number of hours in the day. And so that everything matches up with units, you multiply that by 60 minutes, which would equal 60. Okay, so then you do the same thing for station 2 and station 3. You do 2 times 8 times 60, which was the same thing. And then for this one, you do 1 times 8 times 60, which is 480. Ooh. Okay. So then you come over to product A, and you would see the demand for product A is 50. So you would just put 50 all the way down. And then you would multiply that by the processing time, which is 2, 20, and 1. So that would be 50. I cannot think right now. And 100. Okay. So then you would come over and do the same thing for product B. So you would do 40, since the demand for product B is 40 now, times 20. Got that from there. And that is 100. And then this one, blank, and then 40 times 9, which is 360. Okay, so then you would find the totals, which is just this plus this. So it's 800 plus 100 equals 900. And then this is just 1,000. And then this is 410. Okay, so then to find the implied utilization, you would do 900 divided by 960. So you would take the total and you would divide it by the available capacity. So for this one, that 1,000 divided by 960, and then 410. It's 480. Yeah, 410 divided by 480. So that equals 93.75. 100 from 4%. And 85%. So once you get your implied utilizations down, you look and see. So this one is over 100%. So this is for sure definitely your bottleneck. And then that is your bottleneck, but you have different bottlenecks for A and B. So this would be your bottleneck for station A. But this is your bottleneck for station B. Because station B isn't involved in this, or product B isn't involved in this station. So you have different bottlenecks for each product. But so you look over here And then, so to find the throughput, what you're going to do is you're going to take, since this is below 1, both these are percentages, and since this is below 1, you're automatically going to have, for product B, you're going to have the throughput for product B is just going to be 40 units because the bottleneck is below 1. So it's just going to equal the demand. The throughput for product A is a little bit more complicated because it's over 1. So what you're going to do is you're going to take 1.04 and you're going to divide that by your demand, which is 50, and you're going to cross multiply that with 1 over x. So it's going to turn out to be 50 equals 1.04 x. And then x turns out to be 48.08. So this makes sense. It's not quite at 50 yet, but it's close. This reached what it wanted to, and this did not reach the demand. Diffie.